Hello all. I would like to welcome for the introduction session of part 2 in Mechatronics Lab, that is on Programmable Logic Controllers. Here let us see the contents which I am going to see in this session. The first let us see, we are going to discuss about what are the course objectives and outcomes, what is a PLC, and then major components of PLC, operational sequence of PLC, PLC programming languages, and then we will see the advantages and disadvantages application, and then last it is about the PLC programming and simulation. So here you are going to see a set of experiments which we will discuss in this part 2, that is second part. All these are the PLC programs. So you can see these first two are based on simple logic experiments, and then next set of two are the timer based experiments, simple timer based experiments. Here the same timer based experiments to control for a motor and a pump. Here one such a timer experiment which is used to in a domestic washing machine, and then the fluid controlling using PLC, that is we are going to control the velocity and then the direction of a single acting and double acting actuators or cylinders. And the next, and it is an application level program, that is design and simulate a ladder diagram for car parking. So these are the things which you are going to see in next few sessions. And then here one thing, this particular second part is for 25 marks. So let us see the course objective of this session. So here you are going to know about the PLCs and introduction to PLC, and then later you are going to learn about the PLC programming and simulation using a simulation software. And then next at the end of this part 2 or course, you will be able to draw the ladder diagram for the given specific problem, and then you will be able to simulate the same program using any PLC simulation software, as well as you are going to interface the same program to the trainer kit, PLC trainer kit. Okay. So before going to the actual sessions, let us know what is a PLC means. That is a Programmable Logic Controller. So a PLC is an industrial grade computer which is used to monitor inputs. Depending upon their state, it will make the decisions on its program or logic to control its outputs to automate a machine or a process. So this is a basic definition of a PLC. Here, I will say the PLCs are used to a computer which is used, or a controller which is used to automate a process. That is, it can based on the inputs, it will, or the logics, it will, or the program, it will control the machine or a process. So maybe you can see here some pictures of this is the PLC. Here this particular thing where before PLCs, that is PLCs were somewhere, they were discovered in 1960s to 1970s. Before that, if you want to automate a machine or a process, that is, if you want to say for example, if you have to keep a machine for an hour, and then if you want to switch it off, the effort required to automate such process, maybe such a it requires a hard relay systems, which requires lot of what is that efforts, and then complexity will be involved. So in order to overcome such scenario, such things, in 1960s and 1970s, in this duration, the PLCs were evolved such that they can be efficiently used to automate a machine or a process. Okay, you can see here where a relay kind of systems which were used in earlier days to automate a process or a machine. So if this is what how you can see how complex it was. Later, as said, in the 1960s, they were discovered the PLCs, and then later it has been evolved such that which can be effectively used to automate a machine or a process. So you can see a PLC how it looks. Okay, uh, this is about the basic introduction to PLC. So here you can see the some of the major components of a PLC, which will have a power supply unit and an input and output modules and a CPU and a programming device. We'll see one by one in the next few slides. So here you can see the power supply unit, which is in the PLCs. So the main purpose, the main function of the power supply unit is to provide power supply for the PLC, the whole PLC components. That too, it will function or it will regulate the power supply to the required level to all the components. So that means it will maintain that particular voltage. Say for example, the PLCs will be which will operate at 120 VAC, variable AC source. So this particular power supply unit maintain that voltage to all of its components, such that if any power fluctuations will not go into the that system components. Okay, that's and also if any high voltage, it will indicate if any high voltages are less. So you can see the limit here, 120 or 240 AC voltage will be normally operating range of the PLCs. And the next important part is a central processing unit. You can say which can be said as the brain of an PLC. So you can see which will maintain or which will governs all the activities which run by the PLC systems. So entire activities controlled by this CPU. You can see here how this central processing unit of a PLC looks, which will have so many integrated circuits and microprocessor, and also a memory unit. So which will normally the CPU consists of these kind of blocks, an ALU, arithmetic logic unit, and internal memory for the CPU, and internal timers, counters, and clocks. So what the main functions, the CPU performs the following main functions, such as it will scan the input and output of the sources, and also the program execution will be done by the CPU, data handling, and then peripheral and external device communication. All these are some of the important functions which the CPU will do. So continuing the few more parts, can see input modules and output modules. Input modules, this you can say the PLCs will have. So you can see here how an input or output module will look in an PLCs, like if it is a modular PLC, which will be something like this, input output modules. So which you can see here for this, here we have represented some 7 inputs and 7 outputs for simple understanding. Here you can see the input modules will will receive the signal from these kind of things, that is it may be switches or push buttons or sensors, and this input module will convert the voltage level to the PLCs, and then later an input module will have an isolator that will when sending the signal to the PLCs, such that the voltage should not, the fluctuation of voltages or the signal will be avoided. So input modules will receive the inputs from these kind of devices, such as switches, push buttons, or sensors. And the next, an output module. So here the output modules will work reverse as that of the input modules. So output modules will be generally that is will send the signal received from the PLC to the actuating devices. That maybe some of the actuating devices are the examples. Here you can see here indicator lamp or a motor or a pump. So these are some of the output devices. So these devices will receive a signal from PLCs and then they will work. Okay, and the next it is a programming device. So the programming, that is it's a programming terminal which is used for programming the PLCs and monitoring the PLC's operation. So you can program a PLC with a handheld device or a desktop computer or a laptop computer with a suitable software. You can program here in the computer, and then later the same program can be uploaded into the PLC. You can see here you can connect laptop to the PLC, and then you can upload the program which you have written in the PLC. So these are some of the important major components of the PLCs. So here you can see and how a PLC can be is interconnected with the input output devices. These are the input devices. It may be a stop button or a start button, which will the PLCs will receive an input from these kind of sources, and using these input modules and execute based on the program instructions, the PLC will send a signal to these kind of output devices, so which function according to this the signal sent by the PLCs are controlled according to the signal sent by the PLCs. So these are the elements. You can see motor and an indicator light are all these are the output devices or output elements. So here we will see types of PLCs. There are majorly two types of PLCs. One is a fixed or compact PLC, and the other one is modular PLC. So you can see here how a compact PLCs will looks like. A compact PLCs will not everything will be in a one single module, that is a input output modules and then CPU, everything will be embedded here, and then this particular PLCs, compact PLCs will not have the capability to expand the modules. That is, if you want to expand an input or output module, it is not possible to expand in this compact PLCs. So everything that is input and output will be decided by the manufacturer. So if whatever the inputs or outputs given by the manufacturers, so with that input and output only we have to manage the things. Okay, the next it is a modular PLC. So you can see here how a modular PLC looks like. So here a power supply and then a processor and communication interfaces. You can see here input output systems. Here in the modular PLCs you can any input or output components. If you want to expand input or output modules, you can expand these components. Input or output modules components can be expanded. It is not decided by the man. If the requirement arises, you can add an input or output module to the same PLCs. Okay, so that is the main advantage of modular PLC. So here we will see the how an operational sequence of PLC. How does it operates? So first thing is the PLC checks input status. That is, PLC will take a look of the inputs or outputs and determine what is the condition, whether those inputs or outputs is on or off. All those things it will first it will identify the things, and then later in the second stage it is program will be executed. That is, whatever the program you are going to upload to the PLC, that program will be executed. That is one the executive step by step, one instruction at a time it will be executed. So finally that based on the input status or input or output status, uh, the PLC will update the outputs in each step. So based on the input or status, PLCs will update the outputs in each status, in each in each states. Here in each step, sorry. Here this process will be repeated till the program is finished. Okay. Here we'll see the PLC programming languages. So some of the programming languages which are used by the are in generally used are in the PLC programming languages are ladder diagram, structured text, function block diagram, and sequential function chart. So the ladder diagram is the one which is most commonly and widely used PLC programming languages, and even we are going to in this particular lab, that is in the part 2, we are going to use the same ladder diagram as the PLC programming languages uh, to operate and control the PLCs. So here let's just an in ladder diagram, what is a ladder diagram which will have some of the basic components. You can see these are the basic elements or the symbols which the ladder diagram has. So some like a make, this particular symbol will indicate the make contact and a break contact, and this is an output element. Here ladder diagram is also said as relay logic program, that is which is as just similar to the relay uh, programming, so it is said as relay logic program also. Okay, you are going to see in detail in the this ladder programming session. So here are some of the advantages of PLCs. So they are reprogrammable. So you can in the before PLCs, or if you are using and relay systems to automate, where if the relays are constructed, if you want to modify something, then you need to change the whole circuits itself. Here you can reprogram with the same program, you can modify, or you can write a new program and you can upload to the PLCs. And then complex logics, if you have any complex logics which can be easily represented, that is the one main advantage. And then with a single unit you can control multiple devices. With a single unit you can control and multiple devices in an PLC. Here PLC can be easily scaled up or modified. So if you want to change the PLC from one location to other location, you can easily shift, or if you want to modify something, then you can easily modify the things. So PLCs are generally smaller in size as compared to the hardware solutions. As said, the relay solutions in the first slide itself you have seen. So the PLCs were small as compared to the hardware automation solutions. So if you want to make any changes, in making the changes in PLCs will be easier and faster. And then PLCs will have the integrated diagnostics and override the functions. That is, if you want to, if anything goes wrong, PLCs will indicate what has been gone wrong, and even they can have the rectify those errors. And then diagnostics are centrally available, so applications can be immediately documented. So whatever the things you are going to run on the control on the PLCs, those things can be documented easily using PLCs. These are the advantages of PLCs. So disadvantages are PLC manufacturers offer only closed architectures. So which means if you want to modify these PLCs will be difficult. So PLC devices are proprietary. So the PLCs manufactured by individual manufacturer are proprietary. You can't you can't use if something happens, you can't use the same kind of part of PLC of other manufacturer to the some other manufacturer's PLC. So that is the one thing. And then so PLCs, subject impose or manufactured by semiconductor based systems. That is the one major limitations. And then setup and training costs. So setting up of a PLC, because initial cost will be high, and then training the persons will also takes in or incurs high cost, and then it will have the fixed circuit operations. So these are the major disadvantages of the PLC system. So here you can see the manufacturers of PLCs. So some of the PLC manufacturers are Rockwell Automation, General Electric, Texas Instruments, Siemens, Festo, Toshiba, Mitsubishi. So the list goes on. So these are the some of the major PLC manufacturers, I can say. Okay. Here we see the PLC applications where PLCs are used. So you can see here PLCs are used in cement industries, paper industries, process automation plants such as mining or oil and gas, in boilers and thermal power plants. So glass industries, car manufacturing plants. So here and all you can see the PLCs are operated in the very harsh environments. Maybe you can see, so here you will have the more dust, and then the temperature of the operating conditions will be very high. Similarly here also, so because of these advantages, only PLCs are used for an automation purpose or process automations. Okay, thank you.